The true size of the universe is difficult to determine, as it is constantly expanding and our current technology is limited in the distances we can see. However, astronomers estimate that the observable universe, which is the part of the universe we can see, is approximately 93 billion light-years across. This is based on the distance to the most distant observable objects we can detect, and the age of the universe as determined by the cosmic microwave background radiation. However, there may be parts of the universe that are beyond our ability to detect, so the true size of the universe could be even larger. Hello and welcome to Oz News. Please don't forget to subscribe and hit the bell icon. How big is the universe? It's one of the fundamental questions of astronomy. By looking for the farthest observable point from Earth, and by extension, the oldest given the speed of light, we can estimate a diameter. Thanks to evolving technology, astronomers are able to look back in time to the moments just after the Big Bang. This might seem to imply that the entire universe lies within our view. But the size of the universe depends on a number of things, including its shape and expansion. As a result, while we can make estimates as to the size of the universe, scientists can't put a number on it. In 2013, the European Space Agency's Planck space mission released the most accurate and detailed map, opens in new tab, ever made of the universe's oldest light. The map revealed that the universe is 13.8 billion years old. Planck calculated the age by studying the cosmic microwave background. The cosmic microwave background light is a traveler from far away and long ago, said Charles Lawrence, the U.S. project scientist for the mission at NASA's Jet Propulsion Laboratory in Pasadena, California, in a statement, opens in new tab. When it arrives, it tells us about the whole history of our universe. Because of the connection between distance and the speed of light, this means scientists can look at a region of space that lies 13.8 billion light-years away. Like a ship in the empty ocean, astronomers on Earth can turn their telescopes to peer 13.8 billion light-years in every direction, which puts Earth inside of an observable sphere with a radius of 13.8 billion light-years. The word observable is key. The sphere limits what scientists can see, but not what is there. But though the sphere appears almost 28 billion light-years in diameter, it is far larger. Scientists know that the universe is expanding. Thus, while scientists might see a spot that lay 13.8 billion light-years from Earth at the time of the Big Bang, the universe has continued to expand over its lifetime. If inflation occurred at a constant rate through the life of the universe, that same spot is 46 billion light-years away today, according to Ethan Siegel, writing for Forbes, opens in new tab, making the diameter of the observable universe a sphere around 92 billion light-years. These estimations are further complicated by the possibility that the universe is not expanding in an even manner. ESA opens in new tab, reported on a 2020 study using data from ESA's XMM Newton, NASA's Chandra Space Telescope and Rosat X-ray observatories, suggests that the universe is not expanding at the same rate in all directions. The study measured the X-ray temperatures of hundreds of galaxy clusters and compared that against their brightness. Some clusters appeared less bright than expected, suggesting they were not moving at the same rate. This possibly uneven effect on cosmic expansion might be caused by the mysterious dark energy, ESA stated. Centering a sphere on Earth's location in space might seem to put humans in the center of the universe. However, like that same ship in the ocean, we cannot tell where we lie in the enormous span of the universe. Just because we cannot see land does not mean we are in the center of the ocean. Just because we cannot see the edge of the universe does not mean we lie in the center of the universe. Scientists measure the size of the universe in a myriad of different ways. They can measure the waves from the early universe, known as baryonic acoustic oscillations, that fill the cosmic microwave background. They can also use standard candles, such as Type 1a supernovae, to measure distances. However, these different methods of measuring distances can provide answers. How inflation is changing is also a mystery. While the estimate of 92 billion light-years comes from the idea of a constant rate of inflation, many scientists think that the rate is slowing down. If the universe expanded at the speed of light during inflation, it should be 10 to the power of 23, or 100 sextillion. One explanation for this, outlined by NASA, opens in new tab in 2019, is that dark energy events may have impacted the expansion of the universe in the moments after the Big Bang. Instead of taking one measurement method, a team of scientists led by Miran Vardanian at the University of Oxford did a statistical analysis of all of the results. By using Bayesian model averaging, which focuses on how likely a model is to be correct given the data, rather than asking how well the model itself fits the data, they found that the universe is at least 250 times larger than the observable universe, or at least 7 trillion light-years across. The size of the universe depends a great deal on its shape. Scientists have predicted the possibility that the universe might be closed like a sphere, infinite and negatively curved like a saddle, or flat and infinite. A finite universe has a finite size that can be measured. This would be the case in a closed spherical universe. But an infinite universe has no size by definition. According to NASA, scientists know that the universe is flat with only about a 0.4% margin of error as of 2013. And that could change our understanding of just how big the universe is. This suggests that the universe is infinite in extent. However, since the universe has a finite age, we can only observe a finite volume of the universe, says NASA, opens in new tab. All we can truly conclude is that the universe is much larger than the volume we can directly observe. Determining the shape of the universe presents further challenges thanks to the limits of our means of observation. Like a hall of mirrors, the apparently endless universe might be deluding us. The cosmos could, in fact, be finite. The illusion of infinity would come about as light wrapped all the way around space, perhaps more than once, creating multiple images of each galaxy, according to the University of Oregon Department of Physics. There are plenty more questions about the universe you might want to have answered, such as what if the universe didn't have a beginning? If your thirst for universal knowledge needs more, then these 10 wild theories about the universe might get your mind racing as well. In the 90s, it was often said that the universe is huge, or more precisely 14 billion light-years in hugeness. At the time, non-scientific magazines, documentaries, and popular science didn't necessarily distinguish between age and size. It was easy to assume that the size of the universe was the same as the age, i.e. 14 billion light-years. In addition to this, there was rarely nothing called the observable universe in popular science. Today, it is widely accepted that there is more universe beyond what you can actually see, and there is most likely an infinite number of universes like our own. Let's sort out the old misconceptions. The age of the universe, according to our most precise measurements and observations, is approximately 13.8 billion years. During that time, the part of the universe that we can see, the observable universe, has expanded to 46 to 47 billion light-years in radius. This corresponds to a big bubble with a diameter that is 93 billion light-years. As time goes by, the age and size of the universe will increase. Since the most distant objects will move away from us at an ever-increasing rate, there is a limit to how much of the universe that we will be able to observe. This limit is called the future visibility limit, or future observable universe if you like, and is estimated to be around 61 billion light-years. This corresponds to a sphere with a diameter of 122 billion light-years. Thank you for watching.